Standard definition television is a television system that uses a resolution that is not considered to be either high-definition television or enhanced definition television. The two common SDTV signal types are 576i, with 576 interlaced lines of resolution, derived from the European-developed PAL and SECAM systems, and 480i based on the American National Television System Committee NTSC system. In North America, digital SDTV is broadcast in the same 4:3 aspect ratio as NTSC signals, with widescreen content being center-cut. However, in other parts of the world that use the PAL or SECAM color systems, standard definition television is now usually shown with a 16:9 aspect ratio, with the transition occurring between the mid-1990s and mid-2000s. Older programs with a 4:3 aspect ratio are shown in the US as 4:3, with non-ATSC countries preferring to reduce their horizontal resolution by anamorphically scaling a pillar-boxed image. Standards that support digital SDTV broadcast include DVB, ATSC, and ISDB. The last two were originally developed for HDTV, but are more often used for their ability to deliver multiple SD video and audio streams via multiplexing, than for using the entire bit stream for one HD channel. For SMPTE 259MC compliance, a SDTV broadcast image is scaled to 720 pixels wide for every 480 NTSC lines of the image, with the amount of non-proportional line scaling dependent on either the display or pixel aspect ratio. The display ratio for broadcast widescreen is commonly 16:9. The display ratio for a traditional or letterbox broadcast is 4:3. An SDTV image outside the constraints of the SMPTE standards requires no non-proportional scaling, with 640 pixels for every line of the image. The display and pixel aspect ratio is generally not required, with the line height defining the aspect. For widescreen 16:9, 360 lines define a widescreen image, and for traditional 4:3, 480 lines define an image. SDTV refresh rates can be 24, 25, 30, 50 or 60 frames per second, with a possible rate multiplier of 1001 for NTSC timing accuracy. 50 and 60 rates are generally frame-doubled versions of 25 and 30 rates for jitter issues when using non-interlaced lines. Digital SDTV in 4:3 aspect ratio has the same appearance as regular analog TV without the ghosting, snowy images and white noise. However, if the reception has interference or is poor, where the error correction cannot compensate, one will encounter various other artifacts such as image freezing, stuttering or dropouts from missing intraframes, or blockiness from missing macro blocks. The audio encoding is the last to suffer loss due to the lower bandwidth requirements. Pixel aspect ratio. Television signals are transmitted in digitally encoded form, and the lines are scaled to fit SMPTE SDI bandwidth requirements, as opposed to unrestricted uses such as when lines are rendered or overlaid to a modern computer monitor and modern SMPTE implementations of HDTV. The table below summarizes pixel aspect ratios for the scaling of various kinds of SDTV video lines. Note that the actual image is always contained in the center 704 horizontal pixels of the digital frame, regardless of how many horizontal pixels are used. In case of digital video line having 720 horizontal pixels, only the center 704 pixels contain actual 4:3 or 16:9 image, and the 8-pixel wide stripes from either side are called nominal analog blanking for horizontal blanking and should be discarded before displaying the image. Nominal analog blanking should not be confused with overscan, as overscan areas are part of the actual 4:3 or 16:9 image. The pixel aspect ratio is always the same for corresponding 720 and 704 pixel resolutions because the center part of a 720 pixels wide image is equal to the corresponding 704 pixels wide image.